Okay, guys, circles, their relationships and proofs is Unit 8, our next unit. So we always start a new unit with some definitions. This unit is no different. Here we have pieces of circles. We have the center. It is the point inside a circle that is the same distance from every other point that makes up the circle. That is center. Radius is from the center to the edge of the circle, and that can be drawn anywhere. Okay. It is half the diameter. It is a segment whose endpoints are the center of the circle and a point on the circle. It is the distance from the center of the circle to any point on the circle. Diameter. Okay. It is a radii from the center to the edge, back to back to create a straight angle with another radii. Or it goes all the way through the circle, crossing the center. So it is a segment that has endpoints on the circle and that passes through the center of the circle, and it is 2 times the radius. Our next word is circumference. It is the distance all the way around the circle, or you could think of it as the perimeter of the circle, and it has the equation circumference equals 2 pi radius, or 2 pi r. Now those should have been fairly known to you guys. Here's where we get into some of our new vocabulary. We have arc. It is not arch, and it is not A-R-K as in Noah's Ark. It is the math A-R-C, arc. And it is any unbroken part of the circumference of the circle. And I like to think of it as the crust of the circle. If this is the pie, then I have crust pieces. And an arc can be fairly small, okay, less than half the size. It can be greater than the 180. So it can be just any part of the crust of the circle that is unbroken is an arc. Our next vocabulary is semicircle. It is half of a circle. So I drew in a diameter and copied up the arc of the half, or the semicircle. Remember, that straight line means that I have an angle measure of 180 degrees all the way across. Next, new to you is the definition of a major arc. Now, a major arc is any arc that is larger than a semicircle. Right? So it's greater than 180 degrees. Or you could have a minor arc, which is an arc that is smaller than a semicircle. Okay? So we've got small, big, and exactly half as far as the arcs go. Okay? Next page, new word to you is sector. Now, I've heard the word sector on a lot of like sci-fi or space travel movies, but there is actually a math definition of sector, and it is an area of part of a circle. And very much like arcs, I can have a small sector, I can have a large sector, but sector is just a piece of the circle, and it's the area of that piece. Those of you who play music, whether it be a guitar or the piano, might have heard this word chord, but we are using it in the math definition. It is a line segment whose endpoints are on the circle. So it starts and stops at the circle. And chords can be anywhere in the circle. And if a chord goes through the center point, then it is a diameter. And I haven't drawn one in because we already had diameter in our definition set. But these are chords. Okay. Our next new word, well, it's kind of new, right? Because we just got finished doing trigonometry where we had sine, cosine, and tangent, okay? But the physical tangent is a line, and it is a line to infinity and beyond in two directions, that is outside the circle, and it makes contact in one and only one place on the circle, okay? That is a tangent. Our next word is secant. It is also a line, but instead of being outside the circle, part of it is inside the circle, and it intersects at two places on the circle, but it is a line, and we call that secant. So I want you to add this into your note packet, that a circle has a total degree measure of 360 degrees. Any time, any place, any circle, it has a degree measure of 360 degrees. Okay. So let's look at some examples of some of these words put together. So on page 4, the point of tangency is the point where that tangent line and that circle intersect, okay? So in this case, point egg is going to be our point of tangency, that line to infinity and beyond that is outside the circle, making contact with the circle in one place at the point of tangency is point E. Okay? So let's go back up to the top. What is a chord? A chord starts and stops on the circle. So we have line segment AB as our chord. Now that secant is a line, and it goes through the circle, intersecting at two places. So for instance, line CD, cat, dog, or we could call it line S as in Sam, because we name our lines with 2 points or lowercase script. I better probably write that in, right? So, or line S. Okay. And that tangent point where we've already kind of talked about it would be line M as in Mary, line Mary, because I don't have 2 points to name it with. So I'm going to have to go with its formal name, line M. Okay. So now we get into some of our theory uses. I am not expecting you guys to memorize the theory as much as I'm expecting you to recognize it and be able to use it. Okay? So our first theorem is that if a line is tangent to a circle, then it makes a right angle with the radius, and you can use Pythagorean's theorem of a squared plus b squared equals c squared to find the missing side. Now, in our drawing here, I have outlined the tangent line in pink. I have outlined the radius in blue, kind of blue-red. And that dotted line is a drawn-in hypotenuse. Okay? So that would be our A leg, B leg, C hypotenuse. So a squared plus b squared equals c squared. And we could find, if we had 2 out of the 3, we could find that missing third piece. All right. Our next one is kind of fun. If 2 segments are tangent to a circle, okay, they meet at one and only one place. They are originating from outside of the circle, and they intersect at some exterior point outside the circle. Then those 2 pieces, those 2 tangent segments are congruent, and I have marked them that way. Okay. So let's run through a little bit of the math that we can use these theorems to help us solve problems. Okay. This first one, I have a tangent intersecting a tangent outside my circle. That looks like that ice cream cone. Okay? So my ice cream cone theory says that those two tangent pieces are congruent. So GH and KH are congruent. I am given GH has a measure of 4 plus 2a, and KH has a measure of 5a minus 32. If these are congruent, then their measures are the same. So I set them equal to each other. Then I want my variables on one side, my constants on the other. It just becomes an algebra equation. When I isolate my A, I get that my A is 12 units. And I was going to stop there. Here's my problem. I need to find HG. HG is 4 plus 2a. So I'm not done. Okay. So I've gone over here and I've used 4 plus 2a, plugged in my A answer of 12, and gotten a final answer of 28 units. Okay. Inches, feet, meters, whatever. I'm not given a unit of measure, so I'm just going to call it unit. On the next example on this page, okay, it didn't give you any directions, so I'm going to tell you what the directions are. We are to solve for x. So what we have is a circle with a center O. From O to A is the radius, and it's badly drawn on this, so I wrote it down. A and B, or that line segment, is tangent. Again, it is outside, making contact with that circle at one and only one point. So AB is my tangent. Okay. Now then, OB here, from the center to an external point, meeting up at this tangent line, is a secant. If I extend it, we would have gone on through the circle. But we're going to call OB our tangent. So what are we doing? We're asked to find x. And guys, x is actually the diameter. Okay. So let's see. This is what I've really got. I have got point O to point A to point B and back to O as a right triangle. I am given that from O to B is 25. I got that from here. From A to B is 24. I got that from here. I need to solve for OA. Now, I just put it as a question mark instead of an X because X is the diameter and OA is just the radius. So let's not get confused and remember what we're trying to get to. So if I find OA, then I'm going to have to double it because a radius times 2 equals my diameter. So I did my a squared plus b squared equals c squared, or my radius of OA squared plus my leg of 24 squared equals my hypotenuse of 25 squared. I work the problem, and then when I get to the bottom, I've got my radius is 7 units. So OA is 7 units. But I need to multiply it by 2 to get my final answer of 14 units.